Hi, so I'm going to take a chance to explain some of the background and how to actually use JavaScript packaging to build a package on top of D3 in particular. So the first thing to dive into is a little bit of history. So you can see here, this is an old post on Stack Overflow, and they're asking about the relationship between CommonJS, AMD, and Require.js. One of the reasons I want to share this in particular as a starting point is it's 7 years back, and the and just to show that this is confusing. It's hard to do. There's a lot of different stuff going on in JavaScript. So here you can see that they're asking about CommonJS, AMD, and Require.js. Well, the first thing to say is that the question actually doesn't make too much sense. There's some incoherence here. So there's really two different ways to package JavaScript. That's CommonJS and AMD. These are standards for how to write JavaScript modules. And again, this is as of 7 years ago. Things have changed a little bit, and we'll talk about that with native modules. But here, CommonJS and AMD, these were two different ways to do packaging. So if you scroll down, you look at the best answer, I think they do a good job, right? They're going to say Require.js implements the AMD API. CommonJS is another way of defining modules. So if we skip down, right, AMD and Require.js, right, AMD and CommonJS, these are two things to compare, right? These are two different standards for how to do modules, and Require.js is just an implementation of CommonJS. So they both define different ways to build out modules. We don't need to look at these too much in depth because we're not going to use either of them. But this is where the history comes from and why there's a lot of confusion if you start diving into this. The reason there are two is because AMD is designed for the browser, specifically some of the problems that come up when you're doing browser-based JavaScript development. So it's called the asynchronous module definition. And you can see they say here in their answer, right? AMD is more suited for the browser because it supports asynchronous loading. The AMD was specifically designed for the browser. Require.js uses AMD, and CommonJS, right, is actually a standard that's more designed for using JavaScript on the server. So the reason that there ended up being these two standards is that JavaScript before the newest version in the implementation of ES5 used in that it didn't have a native way to build out packages. It didn't have import and export functions, so or syntax. So there were these two standards that arose, and the reason there are two standards is because JavaScript is used in two places. It's used both in the browser and on a server in something like Node.js, where the JavaScript is actually running on the server and then responding to requests. And then on the client side, right, that's what we've been seeing. JavaScript is all running inside of your browser. There's two different environments, two different concerns, and ECMA script 5, which people call ES5, ECMA script, shortened to ES5, which was the previous version of JavaScript. JavaScript is an implementation of the ECMA script standard. It didn't have a way to do modules, so people kind of came up with ways to do it, and there are two different ways that arose, right? And as of now, there is now ES6. So ES6 is the next iteration of ECMA script. It does include a way to do modules, and we'll dive into that. We'll dive into that a bit. Here, right? This is the history. If we look at the next tab I have here. You can see this is Require.js to say. So Require.js is a JavaScript package, and what it does is it loads JavaScript modules in the browser. So JavaScript module loader. It's designed to load modules in the browser. So it implements the AMD spec. So Node.js uses the CommonJS spec. And actually, I think Node extends CommonJS a little bit, uses stuff that isn't in CommonJS about how you would define a package, because it can, right? It doesn't have to rely on browser support. Node can add features that aren't in JavaScript at all. And AMD, right? This is designed for the browser, and Require.js is a way to load these packages. So Require.js can load up JavaScript packages in the browser. And it implements the AMD spec, the asynchronous module definition. So there's these two definitions. Require.js implements one of them for doing stuff in the browser, and Node.js implements the other one, CommonJS, for doing stuff on the server. So you can read through this post. I don't think you need to, because this is just a bit of history. But there was a lot of thought into why why this AMD was defined the way it does. They really think about the web today. CommonJS is this standard that's implemented by Node, and it thinks about things it works well for things on a server. AMD, it just looks a little bit different, right? And the way it's written actually allows it to load things asynchronously, which is the problem that you have in a browser. Load times, the browser itself is requesting files, and those might be loaded at different times. That's one of the problems. So a lot here on how it goes, and this is all about designing the standard on how it works. So there's a lot of thought into the standard on what AMD is. And if you want more background, you can also go into why web modules. This is, why we want modules at all on the web. Do we need an import syntax? Python, for example, right? You can import modules. That didn't exist in JavaScript. So, people want some sort of import, require. Require is just another way to say import. So this is one way, but I don't want to go too into depth into this either, because this is from 2011. These posts are written. If we jump forward a little bit, in 2013, there's these tools that have started to arise to deal with the two different standards. So you're building a package, right? And you want it to work for people in NPM, people who are using Node.js. You also want it to work for people who are using it in the browser. So there are these tools that exist on top of any way you write your module to compile it to the other type. Right, you can write your module globally, right? So any dependency you have is expected to be global. CommonJS, right, is going to use this require syntax, and AMD uses this define syntax. Just different ways of writing the same thing. This JavaScript code, of course, would expect some dependency to already be loaded. This is kind of, pre any modularization. CommonJS, this is what it would look like if you're writing on the server side, or writing a module for the server. And then this is AMD. So you can actually see that you could go back and forth between these, right? They're not too different. So it turns out you can write your code in any of these three ways and build it in any of the other three. And it turns out there's actually this thing called UMD, the Universal Module Definition. And it looks a little bit crazy. So here's what it looks like. And what this does is if you included this code and you ran it either in something that expects an AMD format or expects CommonJS format or expects a global, it'll work in any of the three. So you can see here, right, if exports is available, it's going to be CommonJS. It's going to run the CommonJS version. If the AMD, right, so these are checking so that this is being loaded by AMD, it's going to run the AMD way. Otherwise, it's going to expect a global. And this is going to actually use any of these three ways to define your module as a global. Now, this is pretty hairy to write. It looks crazy. And so there are tools like Browserify that will take your code written any of these three different ways, build it out into this type of package so that it can be used by any of the three different syntaxes. So if someone's using any of these three, your code will work with it as long as you use it, as long as you define your code out this way. It's a bit crazy. And here's another post diving into this. I'll leave these as resources for you guys. And I wanted to at least go here. So UMD is implemented, is defined here. So this is the actual spec, and you can see that they have a few different ways to do it. And these are just patterns for doing this. So if you want a module that works with both AMD and browser globals, you can do this one. If you want it to work with Node, AMD, and browser globals, you can do this. And this is going to look a lot like that code that we just saw, right? This is what you want to do for your module to work in those environments. Same thing for doing the AMD, the Node side, right? If you have module that exports, etc. So this pattern exists to make code that works on either side. You could write your code with this pattern, or you can write your code. If we go back, you can write your code in any of these three ways and compile it to UMD. Wow. Okay. So a lot going on, and this all deals with dealing with these different types of way JavaScript can be used. So if we jump forward, ECMA script 6, ES6 is the latest JavaScript, and it actually defines an import. So now JavaScript itself has a way to import and export code. So you can read this background. And again, if you want more background, I recommend reading it. And this is ES6 is the latest version of JavaScript. And so you can actually see where this module is implemented. So this gets to the first concern if you're going with the latest JavaScript implementation, right? It's implemented in Chrome, Edge, and Firefox. It's not implemented in IE. It's not available in web workers widely. And so, it's still new. Yeah, so that's just one of the gotchas. If you don't want to design for IE, right, you can just expect to use imports in the JavaScript itself, which is the ES6, the latest version of JavaScript. So there's a lot of detail here: import and export, whether they're available. Okay, so and why you might want to do it. So jumping forward. Okay, we don't need to go into this one. I did mention that there are tools to take care of this for us. So, okay, these are just a few of them. Webpack, Rollup, Parcel, Browserify. We saw the post before. It was, how I learned to stop worrying and love the Browserify. It's just one of the ways to take your code written in any of the, now what we'll see is 4 formats. You can write it as a module, looking like a module. You can write it as, which actually means you just use JavaScript's import function, right? You can write it in the AMD way. You can write it in the CommonJS way, or you can write it expecting globals, right? These tools will then take your code and export it to any of the other kinds. They can export it to the UMD format. They can export it to any of the other formats specifically. So that's what these tools do. Really, the bundle size and ease of use, you can dive in and see what you think for yourself. But I'm going to make a choice for us. I'm going to pick Rollup. And so if we go and head over to Rollup.js, if you want to skip all the history, right, you can just start with Rollup, and trust me that it's going to be a good tool to use. If you're curious about why to choose Rollup, you can go and look at the performance comparison before. It's similar, right? And then people get into how does the syntax for defining a Rollup module look versus the other syntax? Is it easy to use? And the reason that I picked Rollup of all these tools is that it's actually what D3 uses. So here's D3's require package, and you can actually see that in this package, there is a Rollup config. If we go back to the Rollup docs, you can dive in and see what's possible with a Rollup doc. But here, right, this is what a Rollup configs look like. This one's actually going to be the same as the other D3 one I want to show you, but this is what ES6 JavaScript looks like. So you can import stuff, right? You can export stuff. These import and export keywords are what the new part of JavaScript is. And so you can write your code using import and exports. What Rollup is going to do is then print it out in the other ways. So here, right, this is going to build meta.names, importing package.json. So this is D3 require. So what it's going to do is it's going to write out dist d3 require.js, and it's going to write it out as a UMD format, right? So that's our target. The source is index.js. So if we go back and we look at index.js, this is going to be code that's source index.js. This is going to be code that's all written using the ES6 style. So you have exports, right? It actually doesn't look like this has any imports. It doesn't have any dependencies. So let's jump to one that does have dependencies. So let's look at D3 scale chromatic. Here we're at the latest version of it. If we go to the source for this, we're going to see that this has a bunch of exports. Well, it's exporting from these. Yeah, it does depend on some other stuff too. So there are going to be some imports in here as well. Right, we can jump to any of these. So this is using export. Let's dive into any one of them. So let's take a look at colors. Here's an export. So export and import are defined here. And D3 scale chromatic does depend on D3 array. So all that to say that if we go ahead and look at the rollup here, it actually looks the same because this is all written out, all defined by meta, by the package.json. So actually all D3's rollup configs are the same. Here though, right, this is using index. It's compiling out to the UMD format. You could compile it to any other format you want. And you can write your code in the new ES6 way. Cool. And then JavaScript that does want your code as a module can still load it as a module, right? It doesn't need to be compiled at all. It can actually just go ahead and load source index.js. Okay. if we want to go ahead and start writing a package, you might be thoroughly confused by all these different plugins and formats and syntaxes. It's all a bit crazy. I know I was, as it's hard to keep up with as these things roll out. But let's just walk through a simple example, and I think there's going to be as little boilerplate as I possibly can have, and that will hopefully make things a little bit clearer. And we're going to use observable to test our package. So first, what we're going to work through is an example here from NPM. So this is going to be our tutorial we'll follow. We're going to go ahead and create a node.js module. Cool. So here it is, right? You can look along these steps. I'm gonna jump through these hoops and say we already did it. So that's here, NPM example. I jumped back to version 1.0 because this is the initial following the tutorial. You end up with and here are the actual lines you'd run to do it. You end up with some code that looks like this, right? Super simple. And you can see here, right, we've actually written this in the common.js format using exports, right? So we've written it so that it can be required by NPM, and this is very NPM specific. It only has it's only that one code, index.js, right? That's all it is. There's a README and there's package.json, right? This isn't going to say much. Super simple. If you compare this back to something like D3 Scale Chromatic, it can be a little intimidating because the package.json is quite long, right? There's a lot going on. There's a lot on the pretest and the test and all of this stuff. We don't have any of that yet, right? Here, simply, we just have index.js. That can be loaded. So let's go ahead and actually try to load it. So we're going to use observable to do that. This is going to go ahead and try to load that library that we just wrote, which is up on NPM. So we can go to NPM here, right? This is going to be that package that I wrote, NPM example. It's right here. It has these 4 versions, so we're going to be pointing this to 1.0.0. Yeah, so we're going to head and go try to import this module and run it. So on observable, a few notes. Using require and import syntax, there's some notes here. This is a really helpful tutorial. These are notes just on using Markdown, so just trying to write some dependencies here if you want to. So this actually block, right? This is a Markdown. And if we go through here, right, I'm going to try to load it 3 different ways. So I'm going to try to load it using require. So I've tried to use require. It says this is not a valid module, right? So here it's actually going to go ahead and try to load this from the NPM repository, and that didn't work. Okay, so the other thing we can do is try to import it. So import syntax, right? This is actually expecting a module. So I call this the example using require. And if here, right, this is require.js because we're in the browser. This is require.js. It didn't get the AMD spec that it wanted, right? It got that export keyword. Oh man, so that didn't work because this is expecting AMD, and we wrote something closer to common.js. We wrote common.js and Node.js type JavaScript. That didn't work. Okay, so if you try to import it, of course this isn't going to work. This is actually expecting the ES6 version, right, to do the import syntax. So shoot, that didn't work. And then one way we actually can get this to import is there is a service called bundle.run. And what that does is it actually takes the code that it finds on NPM and it actually bundles it up into a format that can be required. So this actually, even though our code didn't define via rollup or anything else how to bundle, bundle.run just tried to bundle our code, and it did. So here we can actually go ahead and require it. So this bundle.run example is going to be on the NPM spec. If we copy this URL, we ought to be able to go there and see. I haven't done this, but let's go check it out. Let's see what we get. Bundle.run. So, okay, you can see here, this looks like UMD, right? So it took our module, took our code right here, right? And it put it inside of the UMD format. Cool, right? It was smart enough to go and figure out what was going on in our code and write our code into UMD. So because our code's in UMD from, let's jump back to this one, we can go ahead and require it using require.js. And cool, we can go ahead and run our package. We loaded our package. we can run our actual script. And if we opened up the console, right, we'd see our print message. I think at this point, we can see what's going to print, probably hello. Let's take a look. This is a message from the demo package. Okay, so if we go ahead and load up the console here we go, right? This is a message from the demo package. And if we go ahead and make a change, run it again, boom, there we go, right? It's working. Our code's working. This is all good. Okay. And, I'll go ahead and discard my edits. Okay, that's what we've got going here. And so next, right, this is a little limiting, right? We're requiring on bundle.run. Maybe that's good enough, and you could just stop here and move on. We're going to start to use a few more advanced tools to allow our code to be used in these different formats. So next, if we go into version 1.1, this is actually going to move our code over to source. So let's take a look at what's going on here. Let's move our code over to source, index.js. Okay, and what is going on here? Here we're using the export keyword, right? So this is ES6 export. You can actually see in my notes. This is use ES6 export. So this is using ES6. If we go back to source, go back to, that's our lint spec. We go back to our package.json. Here we're actually going to use rollup to build out the UMD form. So here, right, our module source index.js, right? That's what our code would look like if we wanted to use it as a module. Our actual code, right? We're going to say our main code, and this is what's going to be used by these tools that distribute the JavaScript from NPM, like JS Deliver and these other sites that will take our code from NPM and make it available for the browser. We're saying our actual code is going to be npm dist npm example.js. And what did we do, right? We went and we ran rollup on source.index, and then we wrote it out to npm example. We told it we wanted to write it out in UMD, and that's the name of our package, npm example. That's it, right? So no rollup config at this point, just a single rollup command and a single lint. You can see that our dev depended on ESLint because we wanted to run this. Actually, our dev should have also depended on rollup. So that seems like a mistake because we do need rollup. Anyway, we'll go ahead and run rollup on this. This builds an output. You can actually see the output is not actually in here. So these tools that deploy our code, we'll go ahead and run these commands from these scripts from our package.json to build it out on their own servers. So a bit like a CI. So if we go and look at what happens here, we're going to see a lot more happy imports here. So first, we can go ahead and just we can require the bundle.run, right? That still worked. It still took our source index.js and bundled it properly. And here we go. If we can actually go now and import this code. We're importing it directly from unpackage. That's what import is where it's going to try to load from. This is one of those places that it tries to load from, like jsdeliver.com, unpackage. These just go ahead and host the code that you push to NPM. So here we can go ahead and import it directly. Sweet. And right, this is now a module, right? It's a JavaScript module instead of just an object from require.js. And then we can also go and require our code directly. So this is going to go ahead and require, I think from JS Deliver is the default where require is going to look, but we could check that. But anyway, this goes ahead and loads it as an object. You really get the same thing you did from bundle.run. But here, this is loading the AMD version. This is loading the ES6 version. We're in the browser, so we don't really care about the common.js version, but you could import it in Node. And importing it in Node is what's going to happen on the test side of this. So if you were to go look at the README here. Oh, I didn't run the test command. If you go back here, how to do it, you can go ahead and test it. Install your module, test.js, run node test.js. So node, right, is going to expect your code in common.js, or what's really the Node.js format, which extends common.js a little bit. So that'll go ahead and run it there. Right, you can see our initial version did write it that way. For if we wanted to do this again, right, we would actually, our code would actually rely on the fact that our package.json says our actual main is this dist, which got rolled up into UMD, so NPM could still load it because it's in the UMD format. So Node could still load it. So even though we didn't use the common.js format here, our code would still work for it, right? Because this is loading the UMD version of our code. Okay, well, this is all cool, but you might have a question of like, well, at least I did. Okay, this is all neat and all. We can bundle up some JavaScript code, but really, I want to use D3, right? I want to have code that has dependencies. So if I have a visualization, I want to build it out on D3 and push my code so other people can use my visualization. We're going to do something like this. So this is master current version, and it's going to add a D3 dependency explicit. So let's go here and take a look at what we have. So we have two functions now, same print message. We export one more function, and this is a function that depends on D3, right? It's just going to print D3.version, and here's our import statement, right? I guess we probably could use require because rollup would be smart enough to figure this out, but let's go ahead and use ES6, right? We can import star from D3. Sweet. So now we have all of D3's functionality available as the D3 global. If we only wanted some of D3's functionality, we could import just pieces of it that we need. But here I don't care about only importing pieces for one reason. So if we go and look at what happens, let's start with package.json. We can see that right here, we're just going to do rollup. It's going to use the config file. Okay, cool. Right, and if we go to rollup, this is what's going to happen now. Shoo. Okay, so node plugin node result. So this is going to, we imported D3. Well, where is D3 from? Well, this is going to go ahead and actually know that to go look on Node.js to find our D3 dependency. And we're actually going to build two bundles now. We're going to build two outputs. The first is going to be NPM example bundle. We're going to build it into a UMD, right? And right, we're going to use node resolve. So this is going to include only the functionality from D3 that it needed. Here it only needed D3.version, right? Because it only needed D3.version, it's not going to include the whole library. Rollup is smart in that it will do what's called tree shaking. It will look at the code that we're importing and only pull in the pieces that we actually need. So it's not gonna bundle all of D3 into here. It's gonna only bundle the version because that's all our code needs. It's smart like that in building the bundle. And that's it, right? We've bundled up D3 into our code. So people don't need to import D3. They can just use our package. That's the bundle. We could also we can also expect D3 as a global. So there our code in the UMD format. So here, right, we're not going to include D3, right? We're not going to include that as a dependency. We're going to say D3 is external. So you could go ahead and load, D3 and then load our module, and it would work. So yeah, this doesn't actually use D3. It doesn't actually include the parts of D3 that it needs. It expects it as a global. So we've got two things we're building out: code with the dependencies, code without. And if we go to package.json, we can see which one we're actually defining as the code that would be loaded. And we're building it without, right? So our code depends on D3, right? So we can actually write down our dependency here. I did include rollup here, so that's good, as our dev dependencies. These are things that are only needed to build the package. They're not needed by our code itself. This is needed by our code. It's the difference between dev dependencies and dependencies. And then these are the code we're actually shipping. So for unpackage, right, that CI server, that hosting service, we're going to tell it which one to give out, and we're going to tell it to give the one that's not bundled, right? So that's this. And if we load it as a module, right, it's also just going to load index.js. Cool. Okay, and we can go ahead and load this one. So here, right, we're using this is our demo. We're using ES6 export and rollup. And we have a global D3 dependency. Right, there's some things here, right? There's a debugger. This is actually super cool. You can plug in any package you want, and it'll tell you the best way to actually use it on observable. And then if we keep diving in, so here you can import it from unpackage as a module. Sweet. We did, right? And it will resolve the dependencies we need itself. Here we load it. Here we go ahead and run it, right? Success. We ran our function that depended on D3. So if I go ahead and require it, right, that's going to go ahead and load the example here, right? And again, right, you can see this is going to be the full link. We can tell it specifically which file we want to require to if we want. And here it goes. It's going to go and work. Bundle.run, right, is still going to work. It's still going to bundle it for us. Cool. Here we're passing version 1.2, right? That's this version. And there's another method called global leak. So if you go look at, sorry for the scrolling, if you go look at this debugger, for old code that's not written in any of these formats, not with the UMD output or with the ES6 syntax, ES6, right? Then you can go, there's a kind of a hacky way to load the code. We're not going to worry about that, right? And another way you can do it is Skypack, right? So this is ES6, but right, it loads it from a CDN. So fine. And there it is. Cool. So that's it. We've built a package. We can go ahead and load it in observable. You can also load it in your web page using a script tag because we've used the require.js syntax, so the AMD format that we've exported. And yeah, this can be used anywhere. We can write code that depends on other packages, and this is the modern state of JavaScript development. So if you look at some of these examples, like NPM doesn't really get you fully rolling. It just gets you a Node.js package, right? And some of these, if you go all the way back to like D3, like, wow, this is pretty complex. It does a bunch of stuff, right? It pushes it all out to the D3 website, right? There's a lot going on here, and some of it you may want, some of it you may not need. So I really just try to keep, I really just try to keep the stuff that you do need here. So this is as simple as I thought I could make it, depending on D3 and doing something practical, right? You can go ahead and start building out your visualization now, and and distributing it for a variety of use cases. So if you want to start building some code, I would start here, right? Version, 1.3, 1.2 will also be fine, and you can go ahead and build out your package and distribute your visualization for the world to use. Cool. Thanks for following along.